Okay, I'm gonna at least start off with introducing myself. I'm Cheryl Moeller, or apparently on my webinar it says High Tech Kids. I'll change that in a second. I'm the executive director at High Tech Kids, and each year we've been hosting a research workshop where we invite experts in the theme for the year to kind of share their expertise about what they work on. And this year we've got some great guests lined up. But before we get to that, I want to do a little bit of housekeeping. We're doing this as a webinar format, so you guys are all muted, but you have the opportunity to ask questions, and it would be preferred if you could ask them in the Q&A button on the bottom. That way, I don't have to keep scrolling, and once they get answered, until they get answered, they're sitting there for us to make sure we have the presenters look at. There's also the chat function, which you're also welcome to chat in there. And I do have some things I'm going to put in there for some resources for you guys in just a minute. So that's a little bit about that. This year, our theme is Cargo Connect. And I'm just going to share a little bit about the innovation project that was shared in the first materials. And one of probably the most important thing to know is that the challenge this year is to identify a specific problem related to making the transportation journey of products better. So it's not about moving people, it's actually about moving products. So if you were thinking about how we make a morning commute easier, that would not fit with this year's challenge. It has to be about transporting products this year. And you're, of course, supposed to research your problem and your solution ideas. And then this year, a little change in the wording that first wants you to design and create a new piece of technology, equipment, or method of transportation that could improve the journey of products. So think about what that might be. What is your innovation? And it can be an improvement on an existing technology. You're also supposed to make a model or prototype to show your solution. If your prototype is kind of complicated and you can't build your own drone, you can draw a picture of it and share that with the judges at our tournaments. As part of the research project, you are supposed to share your ideas, collect feedback on your ideas, and iterate on your solution. So be sure to kind of document how your ideas change throughout your season. And the last part is to create a creative and effective presentation that can communicate your solution at an event. So that's the part where you can show a little bit of your creativity and showing your ideas to the judges. If you're a judge or a coach that's back this year, but you didn't do First Lego League last year, I want to give you a heads up that all of our rubrics have changed. First made some significant changes last year. The rubrics are on our website, and I will put a link a little bit later in the chat so you can look exactly what the judges will be looking at while they're rating your teams. And then let's see. The other thing I want to share, there has been a series on Minnesota Public Radio called Temporarily Unavailable. It's a blog, and they're doing a kind of a podcast thing where they're showing one particular issue in the supply chain issues that have been happening this last year. And I will throw a link up on that. I think there's some really great ideas in there. Some of the topics they had were on the container storage yard, where all the containers are stored for the ships. There's one article is called Why Everything is Out of Stock. Another one about the pay or delay, and some of the importers are caught in a situation where they have to pay to wait or they have to delay in selling, and so they're really kind of caught in a bind. There's a paint shortage out there if you're not aware of. That's one particular article. And then there's other things about the container surges. So I encourage you to kind of check that out if you haven't gotten an idea yet. If you've already got an idea, keep going on your path. But if you're really looking for some challenges, that might be a great resource for you. All right, that was kind of what I wanted to share about some housekeeping thing. Our guests today are Rob Holschback. He works on the oversized and overweight permits at MNDOT. So he knows everything about those big things that are really a challenge to move. And this year, it's even a challenge that you might be solving with your robot if you're working on the wind turbine blade, moving that. And then Julie Whitcher is also from the Minnesota Department of Transportation, and she is a state rail safety engineer, and she also works with the railroads and waterways on how things are moved in Minnesota. And our last expert today is Mike Lindahl from Amazon, and he's going to be sharing a lot about the different logistics of just this, how things get moved from one place to another. And another confession here, Mike is also one of our first Lego League coaches. He's been doing this for about 5 years, so he's pretty experienced on coming up with project ideas with teams. All right. So with that, I think I'm going to pass things off over to Rob. And thank you so much for sharing your time. And I'm going to mute myself and we'll let Rob begin his presentation.
Thank you for being here. My name is Rob Holschback, and I am the Oversized Overweight Permit Chief for the state of Minnesota. I probably have one of the most interesting jobs, or at least I think so, one of the most interesting and dynamic jobs in Minnesota. I work for Oversized Overweight, as I mentioned before, and what we do is issue the special permits to the truck drivers that actually haul a lot of the oversized commodities, overweight commodities that you'll see on our highways and roads. Sometimes they can be as small as a fish house. Sometimes they're as big as a wind blade. Special permit software is used to review and verify oversized overweight load information to ensure that the size and the weight of the load can be routed so that the people on the road that are driving are safe, and so that our bridges and our other infrastructure is protected as well. We also work very closely with the Minnesota State Patrol, the bridge office at Minnesota's DOT, and other stakeholders throughout the state of Minnesota. We're also working very closely with our local partners, like in local government, and our bordering states as well. So we just want to make sure, and our safety is our primary concern. We just want to make sure that everyone is aware and prepared of these big moves as they're coming. So, you know, you get a lot of questions sometimes in oversized overweight because it is very dynamic. And when people ask me, well, how big is the load? I tell them, well, it was as big as a house. Well, I literally mean it was as big as a house. So these are the type of loads that we will issue permits to. So the reality of transporting oversized overweight loads becomes difficult each year, more and more so as the years have gone by. Identifying and maintaining sustainable routes is also becoming more problematic. Oversized commodities are getting larger and heavier each year, making it difficult to compete with the aging road system. And this couldn't be truer than with the wind energy transportation section. The journey of the wind blade is a story that I'd like to share with you today. These blades attach to the wind turbines that create electricity, and they're getting much longer. Today, the average wind blade is about 300 feet long when it's loaded onto the truck. Imagine the size of something like this going down the road. It's nearly the size of a football field. So they are extraordinary in size. Green energy wind farms continue to grow in number across the country, increasing the demand for these large components to be delivered by truck is just on the increase. Sometimes trying to get into remote locations where it's difficult to actually access those sites, basically due to the road design. When you're looking at this picture here and you see these wind towers, did you know that it takes up to 15 trucks to move all the parts just for one wind farm, or for one wind tower by itself? Now, consider one wind farm can have up to 100 wind towers in it. So that's about 1,500 trucks needed to haul all the large components into a wind farm. So, and that's just one wind farm. So that's a lot of oversized blades and components that are on the road that need special permits just to get from point A to point B. So again, getting wind blades from point A to point B is the challenge, not only for the truck driver, but everyone involved in the planning process. Finding sustainable routes, identifying locations where temporary road changes are needed, and just the regional coordination efforts that are needed with state and local governments can take up to a year before a permit is ever issued to move these commodities. What you're looking at here is an example of an engineer schematic where a temporary road improvement was needed at this location because the blade was just too long to make the turn. So as you look at this on the left-hand side of your screen, you can see where the blade originally was coming down from that northwest section, and it needed to make a right-hand turn and then a quick left to continue on to that route. Well, with these wind blades, they're so long and they have such a long swing on the back of them that there was no way for it to do it. When you look at the top part of this picture, you can see where that blade would actually have clipped the top of the building had it been able to, had it been required to actually make that right turn. So what they ended up doing in this particular situation was they took that parking lot right in the middle of the picture there and made a road out of it and put a section where that truck could actually go straight through that, just to continue and maintain a sustainable route. And this isn't uncommon. I mean, when you look at the size of these wind blades again, it is very difficult to mitigate and move through some of the smaller towns and communities. So, some of the questions we get too is, well, why would these go through all the small communities? Well, a lot of times it's our own infrastructure that create roadblocks, whether it's, road construction. Sometimes it's even the height of our own bridges, that make it difficult for these taller loads to try and get underneath. So we have to route them off onto smaller secondary roads, if you will, just to get to their destination. So a lot of times you will see these large loads having to go through smaller communities. So Minnesota's Port of Duluth receives a lot of these wind turbines from across the world, coming from places like China and Europe. Here you see a ship at the Port of Duluth that's loaded with the blades that all came from Spain. So doesn't that make you kind of wonder, how do you make this happen? I mean, again, this is a multimodal transportation system to just move this type of commodity. Just to get from origin to destination, it takes ships, it takes trucks, and even sometimes trains. So the wind blades that arrive by ship are offloaded onto these specialized trucks here that you see, and they're often driven from the port right to their destination, that being the wind farm, somewhere in the United States. Sometimes wind blades will come to the Port of Duluth and they'll go out to the state of Wyoming or South Dakota or North Dakota. So I'm going to share a video. Now, this is kind of a neat video, and this is actually a video of blades being transported from the manufacturer in Spain that I just mentioned to their Castellon port, which is where they load their ships. These videos kind of show the massive size and the complexities of moving these large wind blades. So I'll apologize now. The video quality isn't the best, but still, it still gives you a good idea of how big these really are and maybe what some of the challenges are with the transportation system. So sit back and enjoy. that's it for that video. You know, when you look at that, that is pretty amazing. And I'll tell you, what you just saw in those videos are those same kinds of blades that actually made it all the way here to Minnesota. And what you're looking at here is a picture of a ship at the port of Duluth that came in with some of those blades. So this is where it gets very interesting, right? So here's a couple of these blades when they actually leave the port of Duluth. So in that previous video in Spain, you saw roundabouts, you saw all sorts of different road design. You know, in Minnesota, we're building a lot of roundabouts. They are a very safe means of reducing crashes at intersections, but they do represent and create a significant issue for oversized overweight permitting. So with these long wind blades, they can't just go straight through or go down the normal lane of travel. They have to do special maneuvers just to get through. And this is an example of a move just outside of Duluth in one of our own roundabouts and how that's actually done. Now, when you look at our roundabout designs here too, you can see that the engineers have kind of designed these with wind blades in mind, with sloped curbs, removable signage, a large truck apron on the roundabout circle itself, which help. But you can see even in that short amount of time, just the traffic impacts already, traffic starting to back up, just because it takes a significant amount of time for these to actually maneuver and travel through circumstances such as this. Again, with a lot of these vehicle types, they have special articulating rear axles, so they are hydraulic steering. So there is somebody that walks behind or drives behind in a vehicle and actually steers that vehicle from the backside to help manage that turn. At this particular intersection, they had to remove a bunch of infrastructure. So right now where you see that blade swinging, there was a bus stop there where people would be sitting waiting for their bus. They had to take all of that down for this particular project, which actually was about 170 blades. So for that entire summer, significant changes had to be made just for that specific intersection to mitigate these moves. Here's another situation that we've seen throughout the state with these wind blades getting so large. And again, you go back and you look at our aging infrastructure, our road designs. Back when these were built, you know, things were much different. And now you introduce something like this. Here's an example of a truck that needs to make a right-hand turn. So from left to right, you can see, I'll kind of use my pointer here too. I think you'll be able to see that. But he started here and the driver was going this way. Well, because of the swing, they were unable to make this right-hand turn. So they had to do what's called a three-point turn. So they went straight. They backed this long blade up this angled hill here and then continued forward to make that turn. I actually have a couple of examples of what that looks like on some of our state highways. And when you look at even a big intersection like this, that's a multi-lane divided highway, it's still a challenge for these large wind blades in Minnesota just to mitigate some of the turns. So here again is where someone was attempting a three-point turn just so that they could clear the signs and the signals. Here's another picture of how far that rear overhang is on that blade, where that becomes probably more the critical part where damages can happen just because of that swing being so far out from those rear axles. You can see he's even kind of in the ditch there on that turn just a little bit so he can get back far enough. So it's definitely a very big challenge. And this is why sustainable routes are so important. That's our goal. In oversized overweight permits, the biggest thing that we can do is identify and determine a sustainable route for the duration of a project. And again, when you're talking about 1,500 trucks in a 4 to 5 month period, that's a lot of movement. And you cannot always be, you know, tying up traffic like that at those three-point turn locations where turns need to be managed. So, you know, in summary, you know, moving wind is a challenge for the good of sustainability, right? In the years to come, it's only going to expand. So really, seeing what you've seen and knowing what you know, what is the direction of our future, and what can you be thinking about now that would help improve the transportation system for commodities like this. So that is the end of my presentation, and I think we're open for questions here. Thank you.
Yeah, Rob, that's great. We do have a bunch of questions. I have one before I let everybody else ask. Do they normally move them one at a time, or is it like a big train of these moving down to the wind turbines?
That's a really good question. So we have certain, we'll call them rules, where we normally do not allow what we call convoying, right? So, but in situations like this, we do make exceptions. So these will generally go out 3 at a time in Minnesota, but they have to maintain at least a minimum of a 1 mile distance or even a 15-minute span between, so that when they are making special maneuvers, that they're not tying up a specific intersection for too long, so that one goes through traffic and clear, another one comes through, then traffic and clear, just to kind of keep the pace of things. Because if everybody went through at once, it could tie up an intersection at a busy intersection for 15, 20, 30 minutes. So we try to avoid that.
All right, we've got a good question from Megan, and she says, why don't they use airplanes to drop the blades off?
Megan, I wouldn't that be great? I would love it. Even big helicopters. That would make it so much more easy. I think, the problem is, how would you land the plane close enough to the site, the wind farm, right? So you've got to get, a lot of these wind farms are out in the country. They're in farming communities, they're in rural areas. It would be hard to get the plane in there. Sure. I wonder if, wouldn't it be cool if you could open up the back hatch and you slide it out with a big parachute and you just kind of land it down nice and softly, and then the cranes come in and pick it up. What might have been interesting too to share would have been some of the crane pictures of how they pick these pieces up on site and actually build the wind tower. But those are things you guys can look at too online on Google or YouTube. There's a lot of great information out there. But that's a really good question, Megan. Thank you.
Yeah, and she added that later that the airplanes could have claws to hold those blades. So
yeah.
And then we had another question about how long does it take to transport the blades?
That's a really good question. So that also depends on how far they're going. In this example here that I showed you, these particular blades were going to North Dakota. When they left the port of Duluth at, I think around 5 a.m., they would be laying over in the evening over on the far west side of Minnesota in Crookston, so way up in northwest Minnesota. Depending on the length of these blades, it can take all day just because of the different circumstances with the route, making difficult turns. In a perfect world, probably 5 to 6 hours.
All right, that's great. Could you make a longer truck to get 2 wind turbine parts on one? Is that even possible?
It is possible. They have done that. The longer the vehicle, obviously, the more difficult it becomes for the road structure or design that we have currently. We've already kind of reached the limit as to what we can actually push through within reason. So there's also a couple of other factors that go into this, and these are federal rules and regulations. There's the rule of divisibility. So the federal law says that if you have two pieces of commodity, so if you put 2 wind blades on a trailer and it makes it overweight, then you have to take one of them off. And Minnesota follows that rule. So that's where it gets a little challenging. So we would need some help from the federal government to make something like that work.
This is another good question. How much do the windmill buyers have to pay for this project?
Ooh, that's a good question. I don't know if I can clearly answer that, but millions. So yeah, a single wind tower is $1 million or close to $1 million, I believe. I don't quote me on that, but I think it's pretty close to that kind of a number, because there's a lot of different components. You've got generally 3 wind blades. You've got 3 to 4 tower sections just to build it up. You've got the big generator on the top. You've got there's just a ton of different things. So there's a lot of.
And do they have to play MNDOT as well for all this work to plan this all out?
There are, no, not really. There are situations where temporary road improvements are needed. I don't know exactly how those are necessarily handled at the state level, but no, not at least on the transportation side of it.
Okay. How often do the blades get damaged in transit?
That does happen quite frequently. If anybody's interested and if you want to go to YouTube and check it out, you can see videos out there where there have been mishaps where blades get damaged in transit. Usually it's due to an accident. Most times, though, it's a very safe transport. Everything goes well. Even considering the things that you've seen, it's very rare that they do get damaged.
And we had another good question is, how much do the blades weigh?
The blades can weigh, it'll vary. So, and I'm looking, when I talk about how much the blades weigh, I'm looking at the weight of the blade and the truck. So nowadays, with the blade and truck, we're looking at approximately 100,000 pounds, maybe 125,000 pounds. So you're looking at roughly, 70 to 80,000 pounds for one of these blades.
Here's another good one. How do you identify the tough intersections ahead of time? How do you guys know?
That's a really good question. That's a really good question. So that goes back to our permitting software that we use internally. We also use all the maps and stuff like that. So,
oh boy, there's a bunch of questions here.
But we have
they're really going. I'm trying to make sure that some that you already answered.
With all of our road, we use that. I'm sorry, Cheryl.
Oh, okay. So someone asked, what happens when the blade gets damaged?
That's a really good question. A lot of times they'll either deliver it right to the site and then they'll cut it up and destroy it and haul it out in smaller sections. And then they'll just bring a new blade in. That's typically how I've seen them handle it. Or they will find a roadside stop. Maybe it's a rail yard or someplace like that. They'll drop it off there and go back and pick up a new one. But again, a significant delay to the project if something like that happens.
Right. Okay. I think I'm going to need more time to go over the questions. So if you don't mind saving some for the end, we have some more for you, Rob. But I think we're going to pass it over to Julie. And I will keep watching the Q&A. And if your question's still up there and I didn't feel like we had it answered, we will allow time at the end. But in the interest of time, to make sure all of our speakers get a chance to share, I'm gonna have Julie go next. I'll have her take it away there.
All right. So again, my name is Julie Whitcher. I'm going to talk to you about trucks, trains, and traffic safety today. Just a little bit about how I got here. I went to the University of Wisconsin-Platteville. I have 2 engineering degrees, civil engineering and environmental engineering. I've worked for 2 DOTs. I've worked for 2 consultants. Oddly enough, one of those consultants, I was a highway designer and I worked on Piedmont Avenue in Duluth. And I think some of those pictures that Rob showed might have been Piedmont Avenue. So way back when I first got out of college, who knew that I was going to be working on superload designs and that would follow me through my career. Just a little bit about the Minnesota DOT for those interested maybe in a career in engineering someday in the future. We have a really great grad engineer program. You come out of school and you go into this program where you have, 4 to 6 rotations where you can work in a big variety of things and really get a lot of experience. And then you've got, tons of things that and connections you've made before you really get into your career. I spent a decade in traffic safety and signing, and now I'm in commercial vehicles. So on to the good stuff here. So how does my 2 jobs that were described to you before, I'm the state rail safety engineer, and I'm the program manager for weight enforcement, how do those relate? They seem unrelated at first, but what they really have to do is getting these large vehicles and freight to their destination safely. So I'm going to talk about rail first. We have approximately 4,000 at-grade public rail crossings. I'm responsible for determining what signage and what level of warning goes at every single one of those. So with those 4,000 crossings, about a third of those have active warning devices, which is what you see on the right-hand side of your screen where you have the flashing lights. The others are called passive. I'll talk about that just a little bit here in a minute. With the active warning devices, the lights and the gates, that we have currently installed at about a third of our crossings, we cover about 85% of the trips volume-wise, which we measure by average annual daily traffic. And we cover about 60% of the trains that cross at active crossings. So we cover a majority of the big, heavy traffic. All right, so what is all this stuff that we have for safety? Like I said, here on the left, we have a passive crossing. It has a crossbuck, which is this, a stop sign. It could be a yield sign. And what you can't see here is there's a little ENS sign. I'll talk about that in a minute. Over here on the active crossing, we have gates, which are a little bit difficult to see. They're up and down here. They're in the vertical position, but you've seen those. Those will come down and stop traffic from crossing the tracks when a train is coming through. We have cantilevers at some crossings that will have lights flashing over the top of the traffic. We have the flashers, and we have that crossbuck there again. And what you couldn't really see very well is at every crossing, we have this little blue sign that's going to come up. I'm going to talk about that again in a little bit, but it's called the ENS sign. It's an emergency notification sign, and it's at every crossing. All right, so here is an example of when things went wrong. And here's where my two worlds combine. I know we can't really unmute you here. Normally I ask what happened here. So I will kind of explain it to you. I'll let you look at it and try to kind of figure things out. But obviously that's not the way we wanted anybody's day to end. So and of course FedEx showed up, I apologize. Okay, so we have what we call here a humped crossing, where you can see that the road really ramps up a lot to get up and over that railroad crossing. And this truck got hung up on this railroad tracks, and it couldn't go backwards or forwards. We had a train that approached, and then that gate came down on top of the trailer. And then luckily the train was able to stop. It looks like it stopped just before it made contact with that trailer there. And trains can take up to a mile to stop if they're going fast. They're really heavy and really big. So a lot of times, or what we will do is when we have a crossing that we calculate something can get hung up on, is we will put these low ground clearance signs or something to indicate that this, and we'll do it far in advance or a ways in advance so that there's room for the truck to turn around or avoid that area if at all possible, just so something like this does not happen. Here's another example of a humped crossing. If you notice, we have, there's a piece right in the middle here of this truck that got hung up and now is in the down position, and the back wheels are hanging up in the air, and the wheels behind the cab are also in the air. We've only got two wheels on the ground there. So obviously that truck is stuck and is going to need some help getting off of that train tracks as well. So if you're caught in a situation like this, as a truck driver, as a driver, what do you do when you have a situation where maybe you're stuck on the tracks? So first of all, get everybody out of the vehicle. If you have injuries, someone needs to call 911. And then you need to find that little blue sign that I talked about and call the number and give the dispatch that goes directly to the railroad dispatch. Give the dispatch operator the USDOT crossing number and all of the details. And they can radio ahead to their crews on the trains, and they can have them slow down and stop so that they don't have to slam on their brakes and more than likely hit someone because they didn't know that they were there. We can cause a derailment if the train has to go into emergency mode, and that means a loss of could be a loss of the freight that's on that vehicle. Someone could get hurt, lose their life. None of those things we want to happen. So these are all things that people need to know when they are transporting freight. Here's a little close-up of what that looks like. Like I said, each one of those has its unique 800 number that goes right to the dispatch of the correct railroad dispatch, and there is a number that corresponds to each crossing. Here's where another thing went wrong, and here is one of those wind turbines, a piece of it. I'm not super familiar. I'm guessing that's part of the tower there that's on the right-hand side of the picture. There's the trailer that got struck by the train. And there's the cab over here on the left. I do not believe there were any injuries with this incident here. And I believe what happened is as the truck came up to the railroad crossing, they looked left and they looked right and there was nothing coming. And so they started their journey across the railroad tracks. And one of these trains happened to start up along the way. And once they were too far in, there was really nothing that they could do other than evacuate their truck and hope for the best. Luckily, there isn't, I mean, that trailer is very damaged. I don't know what the fate of that piece of the turbine was, but no one lost their life or got injured that day. And that's one of the things that can happen to those wind turbines if things don't go exactly as planned. Here's another incident where we had someone who made a mistake and turned down a railroad track thinking it was a street. They got stuck on the track. Again, they were able to get out, and they called I think they called 911, who called the railroad dispatch. People make mistakes, and truck drivers and passenger cars are no exception to that rule. So that's why we have those signs, and everyone needs to know what to do in these situations. So I'm going to talk a little bit about some research that we've been working on here in our office or participating in. This is a pumped crossing, like I showed you. This spring, I think it was, we went out and we did some experiments using drones to inspect these railroad crossings. Like I said, we have over 4,000 crossings that I'm responsible for. Within a 3-year period, I need to send somebody out and take 12 pictures at each crossing, multiple measurements and data points. And you can imagine that takes a lot of time. And from the picture here that was captured by my consultant, I'm not sure that you can really tell that that's got quite of a slope to it. And it's quite a hazard to trucks and large vehicles. So we've employed some researchers, and I'm participating in a couple projects to see if we could save some time and money with a research project here with drones. So this is me in the forefront here, and way up in that cloud is the drone. You can see we've got an operator here, and you can really see how they get a really good picture of this crossing surface, these panels, and the tracks. And so we can incorporate the folks that inspect the tracks and my folks who inspect the crossing. And we can do some really fun stuff with software where we can calculate some of these sight lines. So here's an overview on the left of what that crossing looks like. We can run some software, and my little green arrow is missing here in the middle picture, but that is a westbound vehicle. So going from right to left, here's what that person can see. And then we can run it the other way and see what they can see. So those are all things that I need to kind of have a handle on to keep the traveling public safe when they're crossing these railroad crossings, and keep them from interacting with trains and railroads. All right, so switching gears just a little bit, I'm going to give you just a couple minutes of the other part of my job here. Weigh stations. There are 2 things that happen with our weight and safety enforcement program that I'm involved with. We have weight enforcement, where you may have seen weigh stations on the side of the road, where a truck will enter in and they will run over a scale and get weighed to make sure that they are within the legal limits of what that truck is allowed to carry. And this is at the Minnesota border coming in from Wisconsin. This is our St. Croix way station. This is our most complicated way station. You can see this is all off of the freeway. And these are 3 different lanes depending on what our sorter tells the trucks to do. They may bypass the station completely on the left, or they may be directed to go over the south or the north scale on either side of our little building here, and get weighed and make sure that they're within their weight limits. And select trucks are pulled out of these lines and they're given safety inspections, where they are looking for unsafe conditions in the truck, and they are checking for credentials of the driver and all kinds of points of inspection that I won't go into here. But why do we do that, and why is it important? First of all, it's required by federal law, so we have to do it. MNDOT works closely with the Minnesota State Patrol, just like Rob's group, to keep our roads safely. And so our weight enforcement and safety inspections are needed to protect the safety and well-being of the health and operators and infrastructure. And unpermitted overweight vehicles can cause our roads to wear out a lot faster. You can see some of the damage that can be caused by a vehicle that is way too heavy going over parts of our road. So we need to protect our infrastructure for everyone else who needs to use it, and so that it's a reliable system for our freight. Here's an example of a vehicle that was taken out of service at a way station. You can see this inside tire on the trailer and what someone was driving on, and I'm not sure that they were aware it looked like that, but I have to believe it didn't leave the warehouse looking like that. I hope so. But so removing unsafe equipment and unsafe drivers from the road makes it safer for everyone. Removing a unsafe vehicle from the roadway may save a life here in Minnesota. It may protect our freight from getting to our local Target and our local businesses, or it may save a life 2 days from now in Colorado or wherever else that transit was on its way to. So that is all I have for you today. We can open it up for questions if we want, or we can move on to our next. Cheryl, I'll let you.
Julie, we do have questions.
Okay. So
the first one I'm going to let you answer is, how do you know the maximum weight capacity a road can take?
That's a good question. Well, the roads are designed to handle trucks that are usually, a standard truck is usually, depends. It depends on the number of axles that each truck has. And it's really about spreading out that weight over each axle so that you don't have, say, the front of your trailer carrying 40,000 pounds versus, the back of the trailer only having maybe 10,000 pounds. So those need to be spread out throughout the axles to make the force on each tire. That's what does the damage to the roads. And so we have federal regulations and state regulations on exactly what that truck can hold on each axle. And that varies from vehicle to vehicle. And all of the truck drivers, and that's available in our state statutes. And let's see. So a lot of times if we have a truck that's unsafely loaded and it's unevenly loaded, we will have State Patrol will pull those folks off to the side of a way station, and they will have them redistribute their load so that they are having smaller point loads on each of those axles and do much less damage to our roads. So it's not so much about how much can I-94 hold, it's how much pressure is coming from each tire.
Oh, okay. How do they determine the trucks that need to be pulled over at the weigh stations?
Well, there's a lot that goes into that, and it has to do kind of the safety record of the trucking company. So if You have companies that have a very good safety rating. There's a good possibility that they will be asked to bypass the station and be able to go by. If you have a company that maybe is newer and doesn't have as many safety inspections or doesn't have as great of a record, they will get pulled into the station. There are a lot of screening tools that State Patrol uses that I'm not aware of every single decision they make, but a lot of it has to do with the safety record of the company. And then sometimes it's just even the look of the truck. After doing a lot of safety inspections and weight enforcement inspections, the troopers can really get a feel for that truck. Really, I can tell that truck is overloaded by the way it's driving on the road. So they might raise a red flag to the troopers and they may direct them into the station as well. And some of it is random. Some of it is just pulling over trucks to kind of do just a spot check and see where everyone is at. And so they will pull over, say, maybe every fifth truck that they see, depending on the capacity of where they're sitting on the road. And those safety inspections actually help out the companies and the drivers as well, because they need to have a certain number of inspections to improve their safety and improve their rating. So it's good for everyone to have those inspections and pass those.
Okay, we got a question about trains, and
Okay.
question was, how long does it take a train to stop?
It can take up to a mile or longer, and it all depends on how heavily loaded that train is and how much momentum is going. If you have a train that's going really fast, like 60 miles an hour, and it's heavily loaded, it can be up to 2 miles. A mile is typically what you hear, but if you have a really heavily loaded train, it can be even longer than that.
Someone asked, how did that truck well get damaged? Do you know? The picture you showed?
The tire?
Yeah.
Yeah, I think it was wear and tear. And I think it finally just wore through the rubber on the tire, and those were the steel belts that were showing through. But I'm not 100% sure.
Why can't they pull all the trucks through the weight station?
Well, it would be really nice to do that, but I think the trucking company would maybe object to that. There is a little bit of a time loss. It can take 2 to 3 minutes if everything goes smoothly when you get pulled into the station. If there's a big queue or a big line of trucks, it can take longer. And we simply just don't have the capacity here at St. Croix. If we pulled over every truck, depending on the time of day, you could back traffic up onto I-94 and cause a safety issue further back unattended, because we just can't get trucks through fast enough. You know, when 6 o'clock in the morning, when the trucks are coming in and they're all trying to get to their businesses to make their deliveries before 8 a.m., there's really a lot of trucks on the road, and it's would be inefficient to pull over every single vehicle every single time. I haven't calculated exactly how long it would take, but we need to be more efficient and to be respectful of the time that we would be causing the freight industry as well. And so it's a balance between trying to pick the best, or I should say maybe the worst vehicles to pull over. And we also have a bypass system that we are employing. It is a company that many other states use as well. We actually have 2 companies now that truck drivers and companies can subscribe to. And most of them have like an in-cab system. I think there's one in Wisconsin that's pretty obvious when you're going on 94, where they have the sensors hanging over the road. And what it is they have all their information loaded up. They're a subscriber, they have good safety records, and they are usually told to bypass the station because they've already done all their inspections and they have a good safety record. And so we are trusting them to keep going with that safety record. And so that's another way that we are becoming more efficient with our weight inspections. So it's always about moving freight as efficiently as possible.
A good question for James. What happens if they weigh too much?
If they weigh too much, they either have to pull off. We have a parking lot usually at each weigh station. So they have to pull over and either redistribute their weight, or they will need to have someone else come and pick up portion of that freight. If it is a small violation where they're not super overweight, they may be given a violation and allowed to continue on. That's at the discretion of the troopers as well. But for the most part, they need to come and have somebody come and get that extra freight.
Okay. Here's another good question. Are there any sensors or cameras installed at railroad crossings? What information would be helpful for Department of Transportation or engineers to have?
The train, so the railroad companies do have cameras at some locations. Unfortunately, because the railroad companies are private companies, I don't have access to the cameras that are at the crossings. And so they are monitoring that from their large facilities, one of which is in Omaha, which I was in. I don't know if you've seen pictures of our traffic management system here in Minnesota, but Union Pacific's dispatch center makes us here in Minnesota look really, really tiny. They operate in about half of the states, and they have thousands of screens where they're monitoring lots of trains. It's not necessarily at every crossing. I think what would be helpful here in Minnesota, and I don't know if this is how realistic this is, but like I said, we do have a dispatch center here in Minnesota where we have cameras at select locations, at intersections and freeway locations. A really big dream, I guess, for train safety and railroad crossing safety would be to have those kind of cameras at each of the railroad crossings or at the really busy ones, and have a dispatch center to monitor those kind of things.
Okay, and then another question is, why is there a limit on speed of trains in the U.S.?
Well, a lot of what controls the speed of the trains is the design of the tracks. They are self-limiting many times. We have railroad tracks that have been built. A lot of the trains or a lot of the tracks were here long before we had roads. Many times there was a wagon trail, and the trains have been here since the pioneer days or before. And these communities were built up along where the railroad would stop. And so I kind of lost my train of thought. Can you repeat the question?
Yeah, like why are there speed limits for trains?
Okay.
I guess. Yeah.
So some of these, thank you. So some of the tracks have not, obviously they're not from, the 1800s, but some of the tracks are not upgraded to a point where they can handle, say, like a 79 mile an hour track. Most of the freight trains are limited to about 60 miles an hour. And that has to do with the equipment that they have, how heavy each of the lines are, the railroad ties themselves, the railroad rails. That will limit how fast they can go. And it also needs to be able to be entered into our what we call a preemption system. So if a train is coming through and we have a signal light for a MNDOT road, those two things have to talk to each other. So we have sensors and things that will trip the lights to stop the train or stop the traffic from going through so that the train can come through as well. So all those things need to work in concert. And so we need to have speed limits, just like we do for traffic. We need to have predictable speeds so that we can predictably stop the traffic as well. So it's two limiting factors, really. The actual infrastructure of the rails and the interaction with the traveling public.
Awesome. Thank you, Julie. I'm going to have one last question. There's a few more that we can maybe answer at the end if there's still time.
Sure.
But we have one last question. Are there any issues with power lines and railroad crossings? Is that problem?
For the most part, if there is a train load that is unusually high for some reason, there could be some problems there. But there is quite a lot of bridges and railroad bridges and highway bridges that is limiting to how high those can be. So we don't have a lot of interactions with power lines and trains. We've luckily been able to take care of all of those over the years. So there's if everything works correctly, there should be no interaction between a power line and a train.
Awesome. Thank you so much, Julie, for all your information that you shared. We're going to pass it on next to Mike from Amazon, who's going to speak a little bit about all the things about the supply chain. So, let's see if there we go. And Mike's going to share his screen in just a second, and I'll pass it on to you, Mike. Thanks.
Great. Thanks, Cheryl and others. It's really great to hear some of the details about trucks and trains and wind blades and all kinds of things. So thanks for sharing all of that. What I wanted so my name is Mike Lindahl. I'm a software engineering manager at Amazon. And what that means is that I work with various software engineers to build technology that helps improve our Amazon transportation. And we specifically work on some of the freight movement. So that's like big semi trucks around the world. One of the things as I've been a Lego League coach for about this is my 5th year. And so I've really enjoyed the program and really enjoyed working with kids and seeing all the great things that you all do with both robots and the presentations. One of the things that when I step back and think about Cargo Connect and what happened, what I do in transportation is so there's a thing called gross domestic product. Doesn't really matter what it is, but it is the amount of stuff that is sold around the world. And the global GDP is $95 trillion, which is an insane amount of money. One of the things that shocked me when I looked into this is that we spend 10% or $9 trillion on transportation globally, which means that for every $100 that any one of you spend, somebody spent $10 getting that product to you. And so the scale of this problem is humongous. And there's a huge economic opportunity if you can figure out how to make transportation more effective. There's a big economic opportunity for businesses, for innovation, and to help the world be able to help humans survive and live better. And moving cargo really is a global human problem. It's something that we have been working on for a really, really long time. When you look at why people came to America from Europe, it was because they were looking for economic opportunities. As we look at why the railroads were built, it was to allow people and goods to move more efficiently around the world. And I think it's a really exciting problem for all of you to be able to engage with this year as part of the Lego League program. One of the questions that we didn't get to yet around the wind turbines was, why don't we build the factories for wind turbines next to the wind project? And that's a really, really good question. And in fact, 100 years ago, most factories were built near their customers. So you would have a factory in the New York area that served the Northeast. You would have a different factory in Minnesota that would serve the Midwest. You would have another factory in Europe that would serve customers in Europe. And what has happened over time is that as we have found better ways to transport goods, we've been able to have more efficient factories where we have more factories that are specialized in one part of the world that then are able to ship products around the world to customers everywhere. And a lot of manufacturing today has moved to Asia because of various reasons. And so there's a lot of products that are being built in Asia and need to be shipped to other places in Asia, to North America, to Europe, and other parts of the world. And so what I wanted to do is talk for a few minutes about what are some of the reasons why we use different kinds of transportation. We saw in Rob's presentation that to move the wind turbine required trucks, it required ships, and it required other modes of transportation potentially. And we had the question, why don't we use planes to move, or helicopters to move the wind turbine blade? And so I think that those are some of the things that I wanted to talk about briefly here today. So if we step back and think about, we have goods that need to be moved, what do we want while we're transporting those goods? Julie talked a lot, and so did Rob, about safety. That's one of the top, or maybe it is the top consideration when moving goods, is how do we make sure that we're moving them safely so that humans are safe, no one loses their life during the transportation, no one gets injured, and the goods arrive safely. A second thing that we want to think about is fast. The faster we're able to move goods, the happier people are when they get those goods. As shipping has moved more quickly, you can go order products online and are able to get those goods in as little as a few hours, or certainly within a few days. And if you go back 10 or 20 years, that wasn't true. And people really appreciate the speed of transportation. A third thing that we all appreciate is that transportation is as cheap as possible, because your product isn't any more valuable to you as a consumer if it was more expensive to get to you. So the cheaper we can make it while ensuring that it's fast and safe is really important. A fourth thing to think about is environmental sustainability. Moving all these goods around the world burns a lot of fuel. It uses a lot of energy, which can have a negative impact on the environment. And we're all aware of the challenges with global warming. So finding ways to transport goods in a more sustainable way is a benefit. And the last thing that we need to do is make sure that we're accurate as we do this. We need to make sure that the products intended for you arrive to you, and the products intended to arrive for somebody else get to them. And so we want to minimize mistakes in the transportation process. So these are all trade-offs that you might try to research if you were interested in different areas of this, to find ways to build technology to help improve the speed, the safety, the cost, the accuracy, and the environmental impact of transporting goods around the world. And then the other side of this, in terms of the trade-offs, is depending on what you're moving and how much you're moving, you may want to use different kinds of vehicles. Rob talked about how moving those wind turbines was a multimodal transportation problem. And that is true for moving all kinds of goods as well, where they will move from a factory in large quantities. They may get put on a shipping container to go across the ocean. That shipping container can be moved onto a train, which will go to a warehouse where the products are broken down and then distributed to warehouses and customers by planes, trucks, or delivery vans. And so I think each of these are different areas that, as you research for your project, you may be able to find and understand some of the trade-offs and the reasons why we use different kinds of vehicles for moving goods, and understand how those, where there may be opportunities for you to invent new technology at any step of this process. So I want to talk just for a minute about each of these things. I am amazed by how much stuff a single ship can carry. So each of the containers that are on this ship are 40 feet long, and each of the, and this ship is able to carry something like 10 to 20,000 containers. And so it's just a massive amount of things. Looking into and understanding Why we use ships, one of the reasons is because it can carry so much stuff. This is the equivalent of 10,000 or 20,000 trucks. And so it's a huge, there's a lot of cost savings by transporting large quantities of goods. But why do ships use containers? That may be something that would be very interesting to go understand. What did we do before we had container ships? And then one of the other things that I found as a resource that I think was really interesting is you can go onto various websites and see where all the ships are in the world. And so this was an image that I pulled recently of, you can see all of the ships that are traveling around the world. Cheryl mentioned earlier that we have a significant problem right now off of Los Angeles where ships have been backed up. And so that has caused a major supply chain issue. And then the other piece of this that I think was very interesting is you can see right here in Minnesota that the ships include ships that are going on the Mississippi River and other river systems, as well as the Great Lakes. And so you're able to see the local ports and ships that are coming here, right here to Minnesota. We talked earlier about trains as well. A train, as Julie talked about, can be up to a mile long. And so they can carry vast amounts of stuff. And so understanding kind of what the cost trade-off, why would you use a railroad versus a truck? Similar to the ship question, I think is a very interesting thing that you may want to be able to research. And trying to understand when would you use a train rather than a truck or a plane is maybe something that you could research and understand and see if you could invent a better way to help the rail network work. Obviously, trucks are a primary way that goods are transported. It was really interesting to see the examples of how trucks can struggle with different infrastructure in both of Julie and Rob's presentations. And I've seen similar cases around the US and around the world where ensuring that trucks know where they're going, are going to the correct places, and have safe ways to get there is a problem that we can continue to make progress on. And again, the question of why do we use trucks so often? Why don't we use more ships or planes or trains is an area where you may be able to find reasons why, or maybe you can find reasons why we should change how we use trucks. And then the last element that I've got here is around planes, which is the newest of these transportation methods. And the question earlier of why wouldn't we use a plane or a helicopter for large goods like wind turbines? One of the biggest issues is that the physics of planes and the cost of having super large planes is very high compared to some of the other modes of transportation. But obviously, the benefit that a plane has is it's the fastest mode. And so when you have goods that are high value, that you want to get somewhere very quickly and are not super duper heavy, a plane can be your best way to transport those goods. And the question that I've got for all of you, and some of the questions in the Q&A and others had pointed to some of these, is what is next? How can you improve trains, planes, trucks, or ships? How can we create new ways to move those goods? Someone in the comments asked, why aren't we using drones to deliver packages? That's certainly something that people are talking about. There are package delivery robots that people are inventing. We're continuing to work on better technology to plan and optimize how things are going together. Maybe you have an idea of how you could eliminate wasteful steps in the process or come up with a safer way to deliver goods to between factories, warehouses, or all the way to you and me as end consumers. Maybe we need to build bigger vehicles. Maybe we need to have more smaller vehicles to have more flexibility. This is where I think it's really exciting for all of you to be able to go learn more and come up with your own ideas of how we can continue to make transportation safer, faster, cheaper, and more environmentally sustainable. So that's what I've got. I'm happy to answer any questions that people may have.
And we have some already. We've got a good question from Michael. How do you handle temperature sensitive products like bananas or lettuce? How do they travel? That's a great question. So there are
Some of these shipping containers have temperature control built into them. And within the ships and the trucks, there's special power units and ways to ensure that the air conditioner or heater or whatever it is that needs to keep the temperature in line is working properly. And then there are both automated systems and manual processes where people on the ship or truck drivers will be monitoring the temperature to ensure that it always stays within a certain temperature range to keep the goods fresh and healthy.
I have another question about blockchain, and their question was, is it used to track the ships?
Is blockchain used to track the ships? I don't know anything about how blockchain may or may not be being used to track ships. So yeah, I don't know the answer to that. That would be a great question to go research and see if there is something you could share with judges. You might be able to help educate some of us experts.
Okay, and here is, we got a couple questions. What are some ways you thought of being more sustainable for transporting things? So I guess maybe talk a little bit about sustainability.
Yeah, so one big trend in the transportation industry, and you're seeing this with passenger vehicles as well, is finding less polluting, more energy efficient ways to move vehicles. So electrification is a huge trend that is happening, starting with passenger vehicles, and delivery vans, but is being explored for large vehicles as well. So there are companies looking at building electric semi-tractors, and which becomes more environmentally sustainable because you can get electricity more with less pollution. So electrification is one way to look at sustainability. Another is looking at ways so different types of vehicles can move more or less freight for the same amount of fuel. So finding more efficient ways to move goods will have lower environmental impact. So it really comes down to fuel optimizing to be more efficient. So finding ways that are lower cost, or using environmental impact as one of the key things that we're planning for across the logistics network. Those are two examples, at least, of ways that the world is looking into this and trying to solve this.
Another question is, what is the most used way of transportation of goods? Like, how do most things move, I guess? What way?
Yeah.
I don't know. I don't
know that. I'm not certain that I know the answer to that. However, the vast majority of goods move on ships and with containers. And in the US, a huge amount of the goods travel by truck because we have such an extensive road network. But rail is growing now too, because these containers can easily be transferred from ships to rail to trucks. And so that's a big area that multimodal, as Rob had mentioned as well, is a huge growing area in logistics and transportation to aim to minimize the cost and maximize the efficiency throughout the transportation network. Okay. But almost every good that we get in that you have delivered to your house would have many goods, lots of technology, clothing, other things were manufactured in Asia and would have traveled by ship over the ocean to come to the US and then distributed by trucks.
Okay. Is artificial intelligence used to analyze the packages in areas to improve the delivery of certain packages in certain areas? And does the analysis make things more efficient?
I think the answer to that is yes. And using the data that is generated from how packages are moved on a given day or a given week or a given month, and that those packages, whether it's containers or individual packages, definitely analyzing that information using various technologies, artificial intelligence, machine learning, and other algorithms to find inefficiencies and find ways to route the delivery driver's path or the path of the truck drivers, creates huge opportunities for savings, which saves. And if we're able to save time, you save fuel, you save time, you get the packages there faster. You're able to save time for the driver so that they're not, covering the same route back and forth 4 times. So definitely the data that's generated, and this is true at Amazon, but it is also true at every, lots of technology companies looking into logistics.
Okay, we have another question was, how long do things stay on the trucks that deliver straight to houses?
So the delivery vans that is essentially a local delivery. So almost always, whether it's the post office or Amazon or FedEx, generally they have trucks that are loaded in a local area and then are delivered the same day. So usually it would be, packages are loaded onto the truck early in the morning. The truck driver leaves and has a route for the day, generally would be 1 shift. And then they would deliver those packages and then go back to the delivery station where either another driver would take it for a second shift during the day, or else it would sit overnight until it's reused the next day.
Okay. Is it feasible to have robots deliver packages instead of humans?
That is a great question. I think it certainly is possible. The world has done it. Whether it makes economic sense, whether it can be safer, whether it can be faster, whether we could have enough robots to make that be a cost-effective thing to do, I think is an open question. The technology is certainly available to do it, but the cost is not yet reached a point where it has scaled and is obviously not yet the primary way that that packages are delivered.
We have another question. What issues exist with ships being pirated or goods being stolen along the transport chain?
That's a great question. That has historically been a problem, and it continues to be a problem. I don't have any specific knowledge, but I do know that it is an issue. I do know that that shipping containers can be tampered with, that at every step of the way, there could be bad actors who find ways to pilfer some amount of goods. And I'm trying to think now, probably 10 plus years ago, there were stories of ships being taken over around the Gulf of Aden, I think, which is near the Suez Canal on the Horn of Africa, with pirates. And so it is a concern, and safety of crews and ships is certainly something that is an issue. That'd be a great topic for somebody to research. How could you invent a technology that would help you minimize that risk? That would be a really interesting thing to research.
Another question was, what are some challenges that Amazon faced during COVID? Maybe there's some that I'm going to guess you had delivery drivers that were sick and staff that, couldn't work, but maybe there's something that we haven't, non-obvious answer.
So worker safety was the biggest thing that we focused on. How do we re-engineer our processes and our ways of working so that people could socially distance, people could stay safe while continuing to deliver goods that all the people who were staying at home needed. You can research this. I don't recall the number. I think we said we changed over 150 processes or something like this. We re-engineered certain parts. And so ensuring that our staff stayed safe while we were able to keep our operation running was the biggest challenge. And we did a lot of work in a lot of people did a lot of work to figure out how to adapt our systems to help enable that.
Okay. Another one was, how frequently is robot delivery being used, I guess, now, and is it safe or susceptible to stealing?
I think that robot delivery is a really fascinating problem for, for all of you teams to consider researching. And I don't know the answer to those questions. I don't know that anybody does. One of the challenges with robot delivery is you could probably steal the whole robot. And then what would happen? I think it's a really interesting area for everyone to think through. I don't think anybody knows the answer to that yet. And if and as robot delivery starts to happen, we will learn what the biggest problems are and figure out how to solve them.
Okay, I think one last question for Mike, unless, and some of the other ones, if there's a presenter that wants to answer, just type the answer to the student, you can. Some of them I feel like they've been answered before, which isn't why I haven't read them. But well, maybe we'll end in this one. Could you speak a bit about the challenges to a global supply chain of the variety in health and safety and sustainability standards across the globe, which is different in different places?
I'm sorry, can you repeat the question?
So the challenges of the global supply chain and related to the health, safety, and sustainability standards across the globe. So everybody has different rules in different countries for health or safety, or perhaps even packaging. How does that get tackled? That sounds like a big problem.
I don't know. Those are real challenges. Ensuring that we're able to maintain high levels of safety throughout the supply chain is really important. And part of, different parts of the world have different approaches to those problems. And so figuring out when and where do we want to set standards, when and where do we want to require others to have a standard that maybe is higher or lower than what we expect is definitely a huge challenge. And I think, again, throwing it back to the students, I think there may be really interesting ways that you could think about using technology to track, measure, and make sure that people are following minimum standards for health and safety throughout the supply chain. Might be a really interesting kind of project to go learn what's happening today and what additional things could be done in the future.
Great. So as I'm looking at the questions, some of the questions I think are great research projects that I'm reading. I think so. We are successful in getting kids to think about some of the challenges of transportation, and they're coming up with some great ideas already. So I'm going to leave it to your teams to figure out how you're going to research that. I really want to give a big shout of thanks to Minnesota Department of Transportation and Amazon for helping us with this project, and our panelists, Rob, Julie, and Mike. So a little virtual clap here for everything that they did to help us. With that, we are completed for today. So I want to thank you all for participating in First Lego League this year. We're really looking forward to seeing your projects and your robots. And hopefully maybe Rob and Julie will stop by one of our events and kind of see what you guys accomplished. So they're going to be inspired by all the great data that you guys shared with us. So thanks again for participating.
Thanks for having me.
Yes, thank you very much. We really enjoyed this time with you guys, and have fun with this. This is really important for our future and sustainability. So thank you.